Welcome back to our final installment this week. We're going to take a little bit of time together to look at how we can calculate measures of central tendency and variance using SPSS. So we're going to walk through three of the key variables we've already seen this week and do the practice together. As you know, we're using our Emory roadmap for data-informed health transformation to guide our work looking at the data on hospital readmissions. We've spent quite a bit of time looking at strategies for exploring variables, looking at their distribution, central tendency, and variance, and next week we'll talk a little bit about relationships. So in our time together today, we'll review how to calculate those numbers in SPSS, and then look at some of the assignments that we have moving forward. So again, we're going to look at how to view central tendency and variance simultaneously using three variables from our previous discussion. The excess readmission ratio, which is the number used to penalize hospitals for readmissions, the proportion of hospitals who give patients discharge instructions, and then the number of discharges by facility. So let's take a moment and open our data set in SPSS. So now that we have the data set open, let's begin by looking at the excess readmission ratio. In the data set we're working with, that's variable number 19. So let's begin by looking at measures of central tendency and spread simultaneously after we look at the variable graphically. So the graph I'm suggesting should be your first point of entry for understanding the variable and the data that are contained in the variable. Because as we saw in our previous discussions, that visual summary can be very powerful in helping you to understand which measures of central tendency are most appropriate for that variable. So let's do that together. If you can go to the top menu and select Graph. Again, we'll take the chart builder. Of course, the variables in this data set are fine. And let's use the histogram from our gallery. And we'll begin with this heart failure readmission excess ratio. So we can widen our window to see the numbers, the variable names more effectively. We'll scroll through until we find it. Here's the heart failure readmission excess ratio. So we're going to put that variable on the bottom, and let's generate this histogram. All right, you've seen this before. So these data, as we suggested in our previous discussion, very closely follow a normal distribution as illustrated in the blue line here. The mean and the median cluster very close to 1. So now that we know, and we've confirmed again from what we knew already, that this variable is normally distributed, we know that either the mean or the median could be great statistics to summarize and describe these data. So let's generate those. Let's go to the Analyze tab at the top. We'll select Descriptive Statistics, and under Descriptives, we'll then choose Frequencies. So Analyze, Descriptive Statistics, and then Frequencies. We'll pull up this window, and we'll again scroll down until we find the heart failure excess readmission ratio. All right, there it is. So we'll click on the variable, move it over. There's a variable I had from before, so I'm going to remove the discharge instructions by clicking the back arrow. And then if you go to the Statistics tab, it gives you an option of what statistics you'd like to use. So let's begin with the mean as our measure of central tendency and the standard deviation. So we said before that the mean is a great measure of central tendency for data that are normally distributed, and we've looked, at least visually, these data are normally distributed, and so we can match that with the standard deviation. So let's click Continue, and we will tell it, okay, So let's view that output. So if we go here to our summary statistic table at the top, you can see for the excess heart failure readmission ratio, we have 2,993 cases that were used to generate our statistic, and we're missing data on 1,691 hospitals. So it's quite a staggering number of missing data points that we have, but these are the data we have available. So let's look at them. We have a mean of 1 and a standard deviation of 0.08. So relatively small standard deviation. All right, let's go back now and do the same thing for the median. So let's go back up to the top of our window. We've already graphed these data, so we don't need to graph them again. So let's go to Analyze menu, Descriptive Statistics. Under Descriptive Statistics, let's choose Frequencies again. That's the one that gives us the most diversity of options. So we'll select this time, instead of the mean, let's look at the median. And as we look at that measure of central tendency, take a moment to reflect on what the best measure of the variance would be. What's the best measure to describe the spread around a median? So think about that, and then come back and join us, and we'll run this analysis. All right, so hopefully you selected the interquartile range, or the space between the 25th and the 50th percentile. So let's go ahead and tell it to continue. And this time I'll show you another quick trick that you can do in this menu. You can also tell it that you want it to graph a histogram with the normal curve on the histogram. So this is a great time saver if you're running both the histogram and the descriptive statistics simultaneously. All right, so let's run those data. So here we have the 25th percentile, which is 0.9490, 75th percentile 1.0537. So we know that 50% of the values around our median of 0.999 are between 0.94 and 1.0, so a very, very tight interquartile range. You can see that if we graphed those points, our interquartile range would range from about here, 94.94, to 1.05, very tight interquartile range. Gives you individual data points that you can scroll through, not worry about at this point. And then you can see the histogram that we generated using the descriptive statistics menu with a normal curve plotted on top of it. So that is a summary of the measures of central tendency, as well as the variance around the ratio of excess heart failure readmissions. So let's do the same process for these other two key variables that we've been looking at. So let's start with the number of discharges for heart failure as follow-up. And this time let's use our shortcut to generate our histogram at the end. So we'll go again to the Analyze tab, the top, and Descriptive Statistics. Under Descriptive Statistics, we'll choose Frequencies. And we want to remove the heart failure readmission variable that we just ran. And we want to look at the total number of heart failure discharges here. So let's populate it. Now, if you remember from before the distribution, then you can select the measure of central tendency that's most appropriate to it. But if this is your first time exploring the data, you could select both the mean and the median, the quartiles, and the standard deviation all at the same time. And then you can get a graph of the histogram with a normal curve on it. So This gives you one-stop shopping for doing a descriptive analysis of your variable. You can see that the mean number of hospital discharges by facility is 400 and the median is 300. So before we go further, I want you to remember, if you have a mean and a median that are not equal and the median is lower than the mean, what does that mean about how your data are distributed? So take a moment, think about that. With the median lower than the mean, what shape do you expect for your data? And then let's look at the histogram and see if that holds true. Okay, welcome back. Let's take a quick look at our histogram. And here you can see that for the number of hospital discharges, the median is about 300, approximately in here, and the mean is 400, approximately in here. So as you've probably already correctly analyzed, when the mean is greater than the median, it means that the data are left skewed, which is what you see here. More observations are on the left side of this curve than on the right. So if we want to scroll back to our descriptive statistics and look at them, if we were to describe these data using the median, which is the best number of central tendency for non-normally distributed data, we see that the median is 300. The interquartile range is from 150, the 25th percentile, to 451 at the 75th percentile. So if someone were to ask you, how many hospital discharges do hospitals in the United States have, you could tell them using the measure of central tendency and the measures of variance that describe how much spread there is around that measure. You could say 300 discharges for heart failure with an interquartile range from 150 to 541. So let's now turn our attention to the last variable that we looked at in our previous discussion and look at the proportion of hospitals who give patients discharge summaries. All right, so we'll go again to our Analyze tab, Descriptive Statistics Frequencies. I'm going to remove the number of heart failure discharges that we've talked about earlier and talk about the proportion of facilities that created a care plan for their, I'm sorry, not care plan, that's not today, it's another day, discharge instructions. So we'll click on that variable, select it, and we'll pretend for the moment we don't know how the data are distributed, so we'll select the mean and the median, standard deviation, and interquartile range, and we'll tell it to give us a histogram with the normal curve as well. So continue, generate those data. You can see here the mean and the median relatively close, but the median is slightly higher than the mean. And take a moment to think about what that means in terms of the data distribution. We'll look here at the histogram. We'll see that the data are very heavily skewed to the right. And that is consistent with a mean value being to the left of the median. So with these three visual tools, the histogram, the box plot, and the scatter plot, as well as variables, measures that show the measure of central tendency and the variance or the spread around that central number. Hopefully you've seen, using our roadmap of exploratory analysis, how powerfully statistics can help us understand numbers. So let's turn very quickly to what's ahead for you this week in visualizing data, describing central tendency and variance in your assignments. So by Saturday night at 11:55 p.m., please post a response to all three topics, one about visualizing data, central tendency, and variability. Here are the directions for each of those. And you can fill out the data template with steps 1 through 3 and use steps 1 through 3 for both visualizing central tendency and variability. And then by Monday at midnight, please submit a response within your teams. Have a delightful time analyzing data. I look forward to our next conversation.